NASA's Rocket Propulsion Test facilities, including the Stennis Space Center, Marshall Space Flight Center, Plum Brook Station, and White Sands Test Facility, have long been at the forefront of rocket engine testing. But for years, each center used its own data acquisition systems, with varying hardware, software, and architectures. This diversity created challenges. Some systems lacked commercial support, forcing engineers to write custom software for every new configuration. Others were so specialized that collaboration between facilities became difficult, and training new personnel was time-consuming. When NASA's business model evolved after the Space Shuttle era, it was clear a new solution was needed, one that would unify data acquisition across facilities, reduce development costs, and streamline operations. That solution became NDAS, the NASA Data Acquisition System. NDAS was designed as a non-proprietary, modular, and extensible framework that could support rocket engine testing across multiple NASA centers. It represents a modern approach to data acquisition, flexible enough to operate both legacy systems from decades past and the most advanced hardware available today. Built primarily in LabVIEW, NDAS leverages technologies such as the Actor framework and LabVIEW, object-oriented programming, to create a model view controller architecture. This design enables code reuse, efficient module sharing, and scalable system growth. To achieve hardware independence, NDAS incorporates two key abstraction layers, the NDAS translation layer, NXLT, and the NDAS calibration translation layer, NCXLT, allowing it to communicate seamlessly with various hardware platforms. The system is composed of multiple functional modules, including operations and control, engineering unit processing, data display, calibration, and logging. Together, these form a complete suite for real-time visualization, data recording, calibration management, and test configuration control. The impact of NDAS has been transformative. It has reduced cost and development time by allowing engineers to reuse code across facilities. What once required writing new software for each test stand can now be achieved by adapting existing NDAS modules. Training has become faster, collaboration has improved, and all NASA propulsion test centers can now operate on a shared framework. Today, NDAS is being implemented as the primary data acquisition software for the Space Launch System core stage at Stennis Space Center's B2 test stand. While it was originally designed for NASA's propulsion test centers, its potential extends much further to commercial organizations, universities, and other government agencies conducting data acquisition and testing. NDAS isn't just software, it's a new foundation for data acquisition at NASA. By combining flexibility, consistency, and collaboration, it represents a standardized future for rocket propulsion testing, one that strengthens NASA's mission and supports the growing commercial space industry. This concludes today's video. Thanks for watching. If you're looking for legacy NI parts, calibration services, or more technical resources, head on over to apexwaves.com to get what you need fast. We have thousands of NI parts in stock and ready to ship, including legacy and obsolete modules you won't find anywhere else. And if you found this helpful, don't forget to like this video and subscribe to our channel for more product highlights, how-tos, and industry insights.